This is the second video in the Pure Maths 1 course on arithmetic series, and it deals with the sum of an arithmetic series. In the last video we looked at arithmetic sequences. These were sequences of numbers where you had a common difference between each of the terms. Here we add 3 to get from one term to the next. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 13, 13 plus 3 16, etc. Now we're going to look at the how to calculate the sum of a sequence like this. In other words, 4 plus 7 plus 10 plus 13 plus 16. A sum of a sequence is called a series. So this is an arithmetic series, and we're going to find a formula that enables us to add these up simply. Well, first of all, let's consider a very simple arithmetic series, the sum of the first 10 natural numbers. In other words, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Now I want to add these up. How could I do this? Well, there is a trick we could do. I could write them the other way round. So starting with 10, add 9, 8, 7, 6, 5, etc. Down to 1. Well, both of these sums are the same. They're just the same numbers added up, but in a different order. So let's call the sum S, and they're both S. So what I'm going to do is add them up in columns rather than in each row. So if I add two lots of the sum, two S's, we get 2S, and that would be 1 plus 10, 11, plus 2 plus 9, 11, 3 plus 8, 11, and so on. Each of the columns comes to 11. Now I've got a much simpler addition to perform, because I've got all of my all my terms now are 11. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 11s. So 2S is 10 times 11, 110, and therefore S is half of 110, 55. Now I could extend this to not just say the first 10 natural numbers, the first 100 natural numbers. Supposing our sum is 1 plus 2 plus 3 plus up to 100. Writing this round the other way, we'd start with 100, and then 99, and then 98, and eventually we'd end up by adding 1. Of course, that's a large list of numbers. But if I add the columns, 2S is, each column comes to 101. I just need to know how many columns I have, and of course I have 100. So 2S is 100 times 101, which is 10,100. So S is a half that, which is 5,050. This suggests a formula for adding up the natural numbers. If I have n, the first n natural numbers, then you see the sum is, well, it's how many I have, n, and then I have n plus 1. We had 101 here, we had 11 here, and that's because the first column is always 1 plus 100, or 1 plus however many we have. So n plus 1. And then of course that we had 2 of those, so we had to divide by 2, so we have a half of that, and that gives us a formula for the sum of the first n natural numbers. Okay, now we can further develop this for any arithmetic series. Supposing we have the one that I started with, and we wrote it the other way, the reverse way, 16 plus 13 plus 10 plus 7 plus 4. Adding them up in the same way, 2s is 20 plus 20 plus 20 plus 20 plus 20, the same number each time. So that is, in this case, 5 times 20, or s equals 50. Well, what do we have here? Again, it's the first and last term. Each column is the same, so it's the same as the first column. And the first column we have here the first term, and the 16 there is the last term, and they add up to 20. The 5 is the number of terms, and then we had to divide by 2. So it looks like a formula could be expressed as a half of the number of terms times the first term, we'll call that A, and the last term we'll call that L. And that's one formula for the sum of an arithmetic series. There is another formula we can derive if we take a general arithmetic series. The sum is, the first term is A, the second term is A plus D, where D is a common difference. The third term is A plus 2D, and so on, until we have the nth term, which is A plus n minus 1D. Remember from the last video, that was the expression for the nth term. Again, if I write these in reverse, we'll start off with A plus n minus 1D. The next one would be the one before that would be 1 less D, so that would be A plus n minus 2D, and then A plus n minus 3D, and so on until we get at the last term A. Add up the columns, 2s equals, well, the two columns, A plus n minus 1D, that's 2A plus n minus 1D. Next one, 2A, D plus n minus 2D, n minus 1D. The next one, again 2A, and then we have 2D, and n minus 3D, again is n minus 1D. And so on until the last one, again, is 2A plus n minus 1D. So we can see each of the sums of the columns is 2A plus n minus 1D, n terms, and so 2s is n times A plus n minus 1D, dividing by 2, the sum is n over 2, 2A plus n minus 1D. So that is also a formula for the sum of a arithmetic series. So we have two formulae, that one and also the other one, A plus L, where L is the last term. So these are the two formulae. You do need to know how to derive the first of these formulae. You may be asked that in the exam. So a few examples of using the formulae. This one here, example 1. find the sum of this series, 4 plus 9 plus 14 plus 19, and of 20 terms. So the 20 terms of that series, we know the first term is 4, a is 4, we know the common difference, 4 plus 5 is 9, so the common difference is 5, and we know the number of terms, 20. So using the formula n over 2 2a plus n minus 1d, substituting the values, s equals 20 over 2 into 2 times 4 plus 20 minus 1, that's 19, times d, which is 5, which is 95, plus 8, which is 103, times 20 over 2, which is 10, which is 1030, 1030. Second example, find the sum of this series, 2 plus 6 plus 10, and so on until adding 158. Well, we don't know how many terms there are in this series, so we know the first term, that's 2, we know the common difference, well, we're adding 4, 2 plus 4 is 6, 6 plus 4 is 10, but we don't know the number of terms, but we do know the last term, and that's 158. So we could use n over 2 a plus l. We don't know the number n, so we need to find that. Well, we know what the nth term is. Un is 158, and from the previous video the formula for the nth term is a plus n minus 1d, so we know that 158 equals a, which is 2, plus n minus 1 times d, which is 4, and that gives you a formula for n. That's 2 plus 4n minus 4, or 4n minus 2. So adding 2 to both sides, 160 is 4n. So n is 40. Now we can use either formula now. In fact, well, let's using s equals n over 2 a plus l, and so we have s equals 40 over 2, a is 2, l is 158, which is 160, so that's 160 times 20, which is 3,200. The third example is what sometimes are called real life problems or word problems, and it's this. Martha needs to save £1,800 from her earnings to buy a car. In the first month she saves £50, the second £60, and continues to add £10 a month until she has the required sum. How long will it take Martha to save this amount? Well, in order to solve these sort of problems, we have to recognise what sort of problem it is. So let's write down what's going on here. First of all, she saves £50. Next month, £60. The next month, well that would be £70 because she continues to add a £10 each month. So in total, you see, we've got 50 plus 60 plus 70 after 3 months. Well, we're going to continue in the same way until the total reaches 1,800. How long, how many terms, how many months do we need to go before we get 1,800? So what you can see here is we have an arithmetic series. We have terms. Each term increases by £10, so common difference, and we have the sum here. The total is 1,800. So we can use our formula. S equals n over 2 2a plus n minus 1d. We need to find n, how many months or how many values in how many terms we have. We know a, that's 50. First one. We know d, it's 10. That's the difference between each term. And we know the sum is 1800. So substituting 1800 is equal to n over 2, 2a, that's 2 50s, plus n minus 1 times d, which is 10. So that equals n over 2 times 100 plus 10n minus 10, which is n over 2 90 plus 10n. Or if we take out a factor of 10, we get 10 over 2, or 5, 9, 5n, 9 plus n equals 1800. Divide both sides by 5. We get 360 equals n 9 plus n, which if we expand the brackets will have 9n plus n squared, or n squared plus 9n equals 360. But if we subtract 360 from both sides, we get minus 360 equals 0, which is a quadratic equation. This factorizes n. Factors of 360, well, 15 and 24 are two factors of 360. We'll need plus 24 minus 15. So n can be 15, or n could be minus 24. But n cannot be negative. So n is 15, and therefore it takes 50 months to save for the car. Okay. Now please return to Study Smart. There'll be another video on the sigma notation, and then you'll be able to download some exercises in order to practice arithmetic series.